Problem number 9. You mix 75 milliliters of a 0.75 molar sodium hydroxide solution with 110 milliliters of a 1.15 molar hydrochloric acid solution. Determine the concentration of H+ remaining after the solutions are mixed. This problem is very similar to the iced tea problem. Ideally, in a neutralization reaction, the moles of H+ are equal to the moles of OH. This problem implies that we have more acid than base, so we'll have H+ left over. The problem will be solved in this manner. The molarity of H+, this is how we calculate the moles, and the volume of H+, this gives us our moles of our acid minus the moles of OH times the volume of OH minus is equal to, we'll call the molarity total times the volume total. Very similar to the iced tea problem, with the exception that here we have a minus sign instead of a plus sign. There's a big difference there. Now it's just a matter of, to figure out the molarity, I'm a big fan of solving things using variables. MT is going to be equal to MH plus VH plus the moles of the acid minus the moles of the base and this is all going to get divided by the total volume, VT, which is actually equal to, now this isn't exactly perfect here, but it's going to be equal to the volume of the H+ plus the volume of the OH minus. Now it's time to plug and chug, plug in our numbers and solve our problem. So the molarity of the acid is 1.15, and we multiply that by 0.110 liters. And then we subtract this from 0.75 molar times 0.075 liters divided by the sum of these two, which is 0.110 plus 0.075. Turns out that the molarity of the acid, the moles of the acid, is this number right here, 0.1265, and you subtract it from the moles of the hydroxide, which is 0.05625. You get a result of 0.07025 moles, and you divide that by the total volume, which winds up being 0.185 liters, and your final solution is this one down here, that the concentration of your H+ is 0.379 H+. That is how this problem is done.